In today's session, we are going to talk about an application of trigonometry that is related to heights and distances. Today we are going to discuss the concept of angle of elevation and angle of depression. So let's consider the following example. So let us consider a plain road, a horizontal road, okay, on which a man is standing. And if he holds his head in the resting position, then he's going to, his line of sight. So this is the line of his sight. So line of sight basically means the line that his eyes make, or rather the line of his vision, right? So this is called the line of his normal sight. So we call this line of normal sight. This line of normal sight is going to be parallel to the ground, right? So even when we all stand on a flat surface or on any surface, you will notice that your normal line of sight, that is when the head is in the resting position. So head is in the resting position right now. The normal line of sight is therefore going to be parallel to the surface on which you are standing. So this is the head in the resting position, and this is the line of normal sight. Now let's imagine that he wants to see an object up in the sky. So let's assume that the object is a bird. So if he wants to see this particular bird, then he has to lift up his head, and to watch the bird, he is going to look at the bird. So his head will be lifted, his eyes would be lifted, and this is going to be the line of elevated sight. So this is the line of elevated sight. So if you consider the word elevated, then anything that is elevated is basically something that is uplifted or something that is raised, right? So this is the line of elevated sight. Similarly, if he wants to see some object on the ground, then he is going to lower down his head. So for example, let's assume that he wants to see this insect that is there on the road. Then he is going to lower down his line of sight, right? So he is going to look downwards towards the insect, and therefore this particular line is the line of depressed sight. So this particular line of sight is called line of depressed sight. So let's take a look at this again. When the head is in the resting position, the line of sight is called the line of normal sight, right? This is the line of vision, and the head is in the normal position, and that is why the line of normal sight is always parallel to the ground. Now if he wants to look at some object up in the sky, the object could be a bird, it could be the top of the tower, it could be an aeroplane, it could be a kite, it could be anything that is up in the sky or that is above his line of normal sight. Then that particular line of sight is called line of elevated sight. Similarly, if he wants to look at something on the ground, then with respect to the line of normal sight, he has to lower down his line of sight, and that particular line of sight is called the line of depressed sight. Now the angle between the line of normal sight and the line of elevated sight, that is this particular angle is called the angle of elevation. Okay, the angle between, so this is called the angle of elevation. Angle of elevation therefore can be defined as follows. It is the angle between the line of normal sight and the line of elevated sight. Similarly, the angle between the normal line of sight and the line of depressed sight, this particular angle is called the angle of depression, right? So this particular angle is therefore called the angle of depression. So I can define the angle of depression as follows. Angle of depression is the angle between, this is defined as the angle between the line of normal sight, the line of normal sight and the line of depressed sight, right? This is called the angle of depression. Please note that angle of elevation and angle of depression are both measured with respect to the line of normal sight. So let me leave you with this picture for about a minute, and then I'm going to take up some word problems and we will try to draw a diagram with respect to that word problem. So in trigonometry earlier, we have learned how to convert or rather if a figure is given, we have learned how to find the unknown sides of a triangle. Now what we are going to do is we are going to convert a word problem into a diagram and then solve for the unknown height or distance. Okay, so pausing for a minute. So now let us take up some word problems and let us convert those problems into diagrams. So let us consider the following question. The angle of elevation of the top of a house. So there is an angle of elevation of the top of the house, as seen by a man on the ground is 30 degrees, right? So if I were to just think about this particular sentence, so there is a flat ground, there is a house, so all objects will be considered as vertical, right? And it's given, so this is the house, let us label this house. This is the house. It is given that the angle of elevation of the top of the house, so this is basically the top of the house and this particular point is the bottom of the house. The house is perpendicular to the ground as seen by a man on the ground. So this is the man who is standing on the ground. For in case the height of the man is not specified, then for all practical reasons we considered the height of the man to be 0, or it is so small that it is not relevant with respect to the given distances. Now the angle of elevation of the top. So if the man tries to see the top of the house, then which is his normal line of sight? The normal line of sight is basically a line that is parallel to the ground. So this is his normal line of sight. And if he wants to see the top of the house, then the angle made by his eyes with the normal line of sight is going to be the angle shown over here. So this is basically the angle of elevation, Right. This is the angle of elevation, and the angle of elevation right now is given as 30 degrees. So this angle is the angle of elevation, of, now which object is the man observing? The man is observing the top of the house. So this is the angle of elevation of the top of the house as observed by the man, right? And it's given that the man is 300 meters away from the house. So this distance is 300 meters. The vertical line is the house over here, and his distance from the house has to be the house from the bottom, or it is the perpendicular distance, the shortest distance, and this distance is given to us as 300 meters. Now we have to find the height of the house. So let us assign the variable h, and now we have to find the height of the given house. So again, let me pause for a couple of seconds, take a look at the word problem and try to correlate it with the diagram, and then we will solve for h. Okay, so now let us find the right trigonometric ratio to solve this problem. First, let me label the vertices. Let this be vertex M. M is for the man. Let this be the top of the house. So let me assign the variable h, the letter h to the top of the house, and let me assign E to the vertex at the bottom of the house. So I can say that in triangle HEM, with respect to 30, I have to find the opposite side, and the adjacent side is given. So I can say that tan 30 is therefore equal to, the opposite side is h, divided by the adjacent side, which is 300, and therefore 1 upon root 3 is equal to h upon 300. 300 is in division, on the other side it will go to multiplication. So I get 300 upon root 3 is equal to h. And now we should rationalize the denominator. I know that I should divide and multiply by root 3. So 300 times root 3 divided by root 3 times root 3. What I've done is I multiplied and divided by root 3. So I get 300 root 3 divided by 3. So this is 300 root 3 divided by 3, which is equal to 100 root 3 meters, right? And of course, I can now convert this into I can now definitely convert this into decimals. This would be 100 multiplied by 1.732, which is equal to 173.2 meters. So the key to solving problems in trigonometry based on heights and distances is to convert the given problem into the right diagram, and we have seen ample number of questions that help us find the unknown heights and distance in a right angle triangle. So pausing for a couple of seconds before we take up the next question. Okay, let's try the next question now. So let us consider the following problem now. A circus artist is climbing from the ground along a rope So the artist is climbing along the rope stretched from the top of a vertical pole and tied at a point on the ground. So let us now make the diagram. So this is the ground level. There is a pole, there is a vertical pole, that is one of the keywords here. So if you notice, they have given me that there is a vertical pole, and the circus artist is climbing along the rope stretched from the top of a vertical pole, and it is tied to the ground, right? It is tied to the ground. So this is basically the rope. This is basically the rope which is connected to the top of a vertical pole. This is the point A. Point A is the top of the vertical pole. Top of the vertical pole. And point B is the point on the ground. So I know that the pole is vertical. So there's a 90-degree here. This is the bottom of the pole. And the circus artist is actually climbing along the rope. So this is the point where the rope is attached to the ground. Let us label it as C. So this is the point where the rope is fixed. Rope is fixed to the ground. Rope is fixed to the ground. And the circus artist is basically climbing along this rope. So the circus artist is basically climbing along the line AC. The height of the pole is 12 meters. So which is the height of the pole here? AB is the pole, and therefore the height of the pole is going to be 12 meters. And the angle made by the rope, that is angle made by AC with the ground, is 30 degrees. That means this particular angle is 30 degrees, right? This is the angle made by the pole with the ground. This angle is 30 degrees. Calculate the distance covered by the artist in climbing to the top of the pole. So basically, this is the distance covered by the circus artist in climbing to the top of the pole. Let this distance be the distance D, right? The circus artist is starting his climb from here. So he starts the climbing from here and he ends the climbing at the point A. So now we have to find the distance covered by the artist in climbing to the top of the pole. Basically, we have to find the distance D. So let me pause for a few seconds, take a look at the question and try to correlate it with the diagram, and then we shall continue. Okay, so now we need to find a trigonometric ratio that joins the opposite side. So with respect to 30 degree, 12 meters is the opposite side, and the hypotenuse is this rope. So which trigonometric ratio joins the opposite with the hypotenuse? It is the sine. It is the ratio sine. So sine 30 degree therefore will be equal to the opposite length, which is 12, divided by the hypotenuse, which is d. Now how much is sine 30? Sine 30 is half, which is equal to 12 divided by d. And cross multiplying, I get d is equal to 24 meters. Therefore, the distance covered, I can say that the distance covered by the artist in climbing to the top of the pole is therefore 24 meters, right? This is the answer to the given question. So again, pausing for a few seconds before moving on to the next word problem. So let us consider these two questions. Let's make the diagram. A string of a kite is 100 meter long and it makes an angle of 60 degrees with the horizontal. So let us draw a horizontal line. This is the horizontal ground. There is a kite which is flying up in the sky, right? The string of the kite is 100 meters long and it makes an angle of 60 degrees with the horizontal. So the string of the kite, this is basically the string of the kite. This is the string of the kite. The kite is right over here at the top. This is where the kite is located. And the string of this kite is 100 meters long. So this particular length is 100 meters. It is making an angle of 60 degrees with the horizontal. So this particular angle is therefore 60 degrees, right? This angle is 60 degrees. Now it is making an angle of 60 degree with the horizontal. Find the height of the kite. So this is the perpendicular height of the kite. Find the height of the kite. So this angle is 90 degrees. This angle is 90. We have to find the height of the kite. So let this be the height of the kite. And assuming that there is no slack in the string of the kite. So no slack would mean that this is basically the stretched side, right? So let's consider A, B and C. Let us consider A, B and C. AB is the vertical height of the kite above the ground. AC is basically the string of the kite. And angle 60 degrees is the angle made by the string of the kite with the ground. This is the horizontal ground. We have to find the height of the string, which is basically h. Let us now draw the diagram for the next one, and then we will solve both the problems. A kite is flying 60 meters above the ground. So let us consider this to be our ground, right? Let us assume that this is the ground. And there is a kite which is flying 60 meters above the ground. So this is the height of the kite from the ground. This is the perpendicular height. So this height is 60 meters above the ground. This is where the kite is located. Let that be point A, and let B be the foot of the perpendicular from the kite to the ground. A string is attached to the kite is temporarily tied to a point on the ground. So this is the string attached and it is tied to a point on the ground. So this point is where the string is attached to the ground. This is where the string is attached to the ground. The angle of inclination of the string with the ground is 60 degrees. That means this particular angle, this is the angle of inclination of the string of the kite. This particular angle is 60 degrees. Find the length of the string. So where is the string over here? AC is the string. So we have to find the length of the string, assuming that there is no slack in the string. So we have to find the length L, given that AB is 60 meters and angle C is 60 degrees, right? So now we have to use trigonometry to solve both the questions. So in triangle ABC, I now have to find a suitable ratio which will join the opposite side with the hypotenuse, and that ratio happens to be sine. So I can say that sine 60 is equal to the opposite side, which is h, divided by the hypotenuse, which is 100, right? And I know that sine 60 is root 3 upon 2 is equal to h upon 100. And therefore 100 goes to multiplication. So this is 100 root 3 upon 2 is equal to h. And therefore I can say that h is equal to 100 by 2 is 50. So this basically becomes 50 root 3. And that can be 50 times root 3. I know that the value of root 3 is given by 1.732. So this is 50 into 1.732, which is 86.6 meters. So this is how I can calculate the height of the kite from the level ground, right? The length of the string was 100 meters and the height of the kite from the ground is 86.6 meters. Similarly, in the second question also, I have to find the right trigonometric ratio first. With respect to 60 degrees, I have been given the opposite length. I have to find the hypotenuse. So I can say that sine 60 is given by the opposite side. The opposite side is 60 divided by the hypotenuse, which is L, right? And I know that sine 60 is given by root 3 upon 2 is equal to 60 divided by L, right? And now from this equation, I basically have to find the value of L. So cross multiplying, I get root 3L is equal to 60 into 2. And therefore, L is equal to 60 into 2 divided by root 3. Now we multiply by root 3 and divide by root 3. So therefore, L becomes 120 root 3 divided by 3. And 3 and 120 cancels 40 times, and therefore this becomes 40 root 3. That is 40 into 1.732, and that is equal to 69.28 meters, right? So this is how I calculate the length of the string. Again, the key is finding the right trigonometric ratio based on what is given and what is asked in the question. So again, let me pause for a few seconds before I move on to the next one. So let's move on to the next question now. Let us consider the following questions. An observer 1.5 meters tall. So in this case, they have given us the height of the observer. So this is the flat ground. An observer 1.5 meters tall. So the observer is 1.5 meters tall, is 28.5 meters away from the tower. So there is a tower. So you will notice that when I draw the diagram, as I read the question, I draw the diagram. This is a tower and this is the observer. The height of the observer is 1.5 meters. The distance between the observer and the tower, that is the horizontal distance, is 28.5 meters. The observer and the tower make a right angle with the ground, right? So these two angles are 90 degrees. The angle of elevation of top of the tower. So this is basically the top of the tower. This is the top of the tower and this is the bottom of the tower. The angle of elevation of the top of the tower from her eyes, that is this particular angle, is 45 degrees. So considering that this observer is right over here, right? What is the normal line of sight for this particular observer? The normal line of sight is going to be a line which is parallel to the ground. So this is the normal line of sight. And this is the elevated line of sight. So to view the top of the tower, the observer has to raise the head, and this is the elevated line of sight. This is the elevated line of sight. The angle between the normal line of sight and the elevated line of sight, that is this particular angle, is given as 45 degrees. Now what we have to do is we have to find the complete height of the tower. So from the top till the bottom, we have to find the height of the tower. That is, we have to find this particular distance, correct? So we have to find the height of the tower. And now we have to see how to find this height of the tower. So I can first consider that, let me label the points first. So A, B, C, D and E, these are the points. So I know that ABDC or ABCD is actually a rectangle, right? And since it is a rectangle, I know that the length BC is equal to AD, and that is equal to 28.5 meters. So this particular horizontal length is therefore 28.5 meters. It is given that the angle of elevation is 45 degrees. So if you consider this particular triangle, if you consider the triangle AED, I can say that in triangle AED, I can now use a trigonometric ratio. I need to find the height of the tower. So height of the tower can be split into two parts. Height can be written as ED plus DC. Now with respect to 45, ED is the opposite side and 28.5 is the adjacent side. So I can say tan 45 degrees is equal to ED divided by AD. Tan 45 is 1, which is equal to ED divided by 28.5, which means the length ED is equal to 28.5 meters, right? So this particular height is therefore 28.5 meters. And I know that CD has to be equal to AB, again because it is a rectangle. So I can say that the length CD is equal to length AB, and that is equal to 1.5 meters. And therefore the height can be calculated as ED is 28.5, so that's 28.5 plus DC is 1.5, so 28.5 plus 1.5 basically becomes 30 meters, right? This is how I can find the complete height of the tower. So pausing for a few seconds while you take a look at this question, and then we will draw the diagram for the next one. Let's take a look at the next question now. An electrician has to repair an electric fault on a pole of height 4 meters. So let us go ahead and quickly draw a pole. So this is the ground, horizontal ground. There is a pole of height 4 meters on this particular ground, right? And now I have the pole is perpendicular to the ground. So this height is therefore 4 meters. An electrician has to repair an electric fault on a pole of height 4 meters. He needs to reach a point 1.3 meters below the top of the pole. So this is the top of the pole. He has to reach a point which is 1.3 meters below the top of the pole. So this height is 1.3 meters to undertake the repair work. So this is where he has to reach. What should be the length of the ladder so that when the ladder is placed at an angle of elevation of 60 degrees? So the ladder is going to be placed at an angle of elevation. So this is basically the ladder. This ladder is going to be placed at an angle of elevation of 60 degrees. So this particular angle is therefore 60 degrees, right? And now we have to find the length of the ladder. So we have to find the length of DC. So now with in triangle BDC, now I have to find the right trigonometric ratio that joins the opposite side with the hypotenuse. hypotenuse needs to be found. So I can say that sine 60 is going to be the opposite side. So now how much is the opposite side? Is BC equal to 4 meters? No. BC is not equal to 4 meters. AB is equal to 4 meters. So I know that the length of AB is 4 meters. And the length of AC is 1.3 meters, which means that the length of BC is 4 minus 1.3, which is basically 2.7 meters, right? So sine 60 degrees will be equal to BC divided by the hypotenuse, which is DC. Now sine 60 is root 3 upon 2, which is equal to BC is 2.7 meters divided by length DC is to be found. And therefore cross multiplying I get root 3 DC is equal to 2.7 into 2 is 5.4, which means DC is equal to 5.4 divided by root 3. Now we can multiply and divide by root 3. So this becomes root 3 upon root 3. And that is equal to 5.4 root 3 divided by root 3 into root 3 is 3. And 5.4 and 3 simplify by 3, it becomes 1.8. And therefore the length has to be 1.8 times root 3. Now I can definitely substitute the value of root 3 as 1.732, and we can therefore calculate this particular value, and that's going to be 3.1176 meters. So this should be the length of the ladder that should be placed so that the repair work can be undertaken. So again, pausing for a few seconds so that you can take a look at the solution, and then we will move on. Moving on to the next set of questions. So let's take a look at the following questions. From a point on the ground 40 meters away from the foot of the tower. So there is a tower. So let's draw the ground. Then there is a tower here, right? From a point on the ground 40 meters away from the foot of the tower. So where is the foot of the tower? The foot of the tower is situated right over here. This is the foot of the tower. So 40 meters away from the foot of the tower. So there is a point here, which is say point A. And this is 40 meters away from the foot of the tower. The angle of elevation of the top of the tower. So this is the angle of elevation. This is the angle of elevation because this is the normal line of sight. AF is the normal line of sight and AT is the elevated line of sight. So this angle is therefore 30 degrees. The angle of elevation of the top of a water tank on the top of the tower. So on top of the tower, there is a water tank that is situated. So let us draw a water tank here. This is a water tank which is situated on top of the tower. So please note that this particular part is the tower and this particular part is the water tank, right? the angle of elevation of the top of the tower, top of the water tank from the same point. So the angle of elevation of the top of the water tank from the same point, that is this particular angle, is found to be 45 degrees. Now we have to find the height of the tower. So we have to find Ft and also the depth of the water tank. So the depth of the water tank is Wt, right? So this is how we have drawn the diagram for this particular question. Let us now try to draw the diagram for the next question and then we will solve both the problems. A person standing on the bank of a river. So let us assume that this is the river. Okay. So please note that the river is flowing into the screen right now. Okay. Or if I were to draw a 3D diagram, then this is the river that is flowing. This is the river flowing and a person standing on the bank. So this is one bank. This is bank 1 of the river and this is bank 2 of the river. A person standing on the bank of a river, let the person stand over here, observes the angle subtended by a tree on the opposite bank is 60 degrees. So there is a tree situated over here and he notices that the angle subtended by this tree is 60 degrees, meaning the angle of elevation of this tree, of this particular tree, is therefore 60 degrees. So this whole angle is therefore 60 degrees. So this is the width of the river and this is the height of the tree. Now let's read on. When he retreats 20 meters away from the bank. So retreats means he comes back, that is he goes away from the bank, that is he comes back 20 meters away. So this length is 20 meters and this is the new point. When he retreats 20 meters away from the bank of the river, he finds the angle to be 30 degrees. So now he finds the angle of elevation to be 30 degrees. That is, this particular angle is therefore 30 degrees. Now what we have to do is we have to find the height of the tree. So this angle is a right angle. We have to find the height of the tree and we have to find the width of the river bank. Rather we have to find the width of the river, right? So let W be the width of the river and let H be the height of the tree. We have named this point. So this is point P, this is point Q, this is point R, and let this be point S. So I'm going to pause for a couple of seconds while you take a look at these diagrams and then we are going to continue and we will solve these two questions. So pausing for a minute or so. So consider the first diagram. Now I want to find the height of the tower. I could first consider triangle ATF, right? If I consider triangle ATF, I know that the angle is 30 degrees. So I know that the length AF is 40 meters. So I can easily find FT. The right trigonometric ratio that I should choose. So I want to find the opposite side. I know the adjacent side is going to be tan. So tan 30 degree is going to be, the opposite side is FT. The opposite side is FT divided by the adjacent side is 40. And tan 30 is 1 by root 3. So this is going to be FT by 40 is 1 by root 3, which means that the height of the tower FT is given by 40 divided by root 3. This is the height of the tower. Now, of course, you can rationalize the denominator and find the height of the tower. Now we need to find the height of the water tank. So let us do that quickly. I know that I can take the triangle. I can now take the complete triangle, that is triangle. I can take triangle AWF. So I can say in triangle AWF, I can say that in triangle AWF, again I can use tan. So tan 45 degree is going to be the whole length, that is WF, divided by the adjacent side, which is 40. And I know that tan 45 is 1, which means WF is equal to 40. Now if I want to find the height of the water tank, so WT will be found out as WF minus TF. Now WF is 40 and TF is 40 upon root 3, and therefore this can be calculated as 40 times 1 minus 1 by root 3. So now you could of course rationalize the denominator here, and let me quickly show that. So FT is therefore multiplying the numerator and denominator by root 3, you get 40 root 3 by 3, and now you can substitute root 3 as 1.732 to calculate the value of FT. And similarly here also you can rationalize the denominator. So this will be equal to 40 times 1 minus root 3 upon 3. And of course I can substitute the value of root 3 as 1.732 and divide it by 3 and then subtract it from 1 and multiply by 40. So this is how I can solve the first question. Now let's take a look at the second one. So this is a typical example where you have two variables and you have you have W and H as your variables, and therefore to solve a two variable problem we need two equations. The first equation can be built using triangle PSR. So I can say that in triangle PSR I can say that tan 60 is going to be H upon W, and tan 60 is root 3. So root 3 is equal to H upon W, which means H is equal to root 3 times W, right? This is the first relation that I obtain based on the given figure. And now I will have to take the bigger triangle to find my second equation. So let's consider the bigger triangle. So I can say that in triangle QRS, I can say that tan 30 is equal to the opposite length, which is H, divided by the adjacent length, which is 20 plus W. And therefore I get 1 by root 3 is equal to H upon 20 plus W, and cross multiplying I get 20 plus W is equal to H root 3, right? So this is the equation. And now what I can do is I can now substitute H as root 3W. I can substitute H as root 3 times W, that is from the first equation. So I get 20 plus W is equal to root 3W multiplied by root 3, which is 20 plus W is equal to 3W. And from this I get W equals 10. And if W is equal to 10, then H is 10 root 3, right? Because H is root 3 times W. And this is how I can find the values of W and H. And therefore the width of the river happens to be 10 meters. The width of the river is W, so width of the river is 10 meters. And the height of the tree is 10 root 3, that is 17.32 meters, right? So this is how I can solve this particular question. And we end our today's session over here. So I will pause for a minute while you take a look at the solutions, and we will solve more questions in the next session. Ending today's session here.